Alright, so this is another devlog, and this time around you need to hear what I hear on my computer. So I'm adding some music back, and let's play, because this is all about audio. This is what I did. I created this audio class that basically loads an audio and then can copy and or manually implement it myself, because an audio, it turns out that it is just a vector of like this int 16 numbers, right? And then you have the sample rate that basically means how many of those integers are passed to the audio stream per second. This is the sample rate. And it is usually like 44,100. I don't know who came up with this number, and I don't care honestly, but it is what it is. And then the audio internally use STB Vorbis, as I said, to load the audio file, so it's great. And there is nothing else. It's very simple, actually, very simple. And I'm only supporting stereo. And then I have the audio device. The audio device is also very simple. I can create and delete a device. It does have a sample rate, and it does have a play function. The play function does have the audio that I want to play, how many loops you want, and if you put 0, it will play once, and if you put a negative number, it will play forever. The volume, of course, it's default to 1, and pitch, I've implemented pitch. And all that below is a bunch of functions to change an existing audio, because the play function returns a handle that is just an ID, and then you can check if this ID is valid and do a bunch of other stuff, right? Internally, it does a bunch of other stuff, and what is cool about this is that initially I was trying to implement this my own using Windows API. Turns out that I'm very bad at audio. I don't understand it very well. I'm getting better on it, but Windows API is just too much. It was a nightmare. So I ended up using a library, a very simple one called miniaudio, and I fell in love because it's good. It's very well documented. They do have a low-level API, which I ended up using because I'm loading my own audio. I like this to have my own format, so I'm using OGG, and then I use like the STB Vorbis to load the OGG, and then I just store the raw format as I showed to you. This is not compressed at all, and I like this way, so I decided to use a low-level API. So I basically needed to implement a data callback and do all the mixing myself, which was very interesting to learn. And it was straightforward once I read all that. So this is me creating the configuration, assigning it 16 bits as the format. I have stereo, so the number of channels is always 2. Sample rate as you initialize. Then I have my callback. And the callback, basically, by the way, everything the play does is it appends like to the queue of currently being executed audios the audio, like the ID, how many the audio, how many loops, the current cursor of this audio, so you can move forward and so on. So it's very simple. But what is interesting here is the callback, the audio device callback, because this is basically called internally by miniaudio, the library, whenever it needs more data to feed into the audio buffer. And then it takes the device here, and I can cast this, I can pass an user data to pass my audio device itself. And there's an input, which is not used. This is if I wanted to get like the microphone input. It's here, but I'm not using it. And this is the output where I actually need to write the data. And this is the frame count, how many frames I need to write into the output. So what I basically do is I prepare a mix buffer, and then I iterate over every single handle of the currently being executed audios, and then I do the mixing right here. So I mix this with the existing ones. And there's a bunch of other stuff. I'm handling loops here, so the audio can loop. I'm also handling volume, and I've made the volume left and right, so we can do like stereo 3D audio, which is great. It's not exactly implemented. I don't have APIs for it, but it is here. So it's great. And I have the master volume, and I even have the pitch, and I also compensate if if you play an audio that does have a different sample rate from the device audio, which is great, right? So I compensated. I'm not sure if this is the right way to do it, but it is a way that I found, and I'm very proud because it works. So yeah. So yeah, it does everything, mix the audio, adjust the pitch, adjust the volume, and so on, which is great. And then in the end, it basically removes all the audios that are finished and also decrements the loops for the handles that are not finished and positive, right? And so that's it. And then in the end, it copies the entire data into the output buffer, right? So very, very simple. And if I play this and press space, see, it works, and it's amazing. I'm very happy. And as a matter of fact, this implementation is actually better than the one that I have in Cave Engine, which is very interesting. Cave Engine audio implementation is terrible, beyond terrible. Gave me a lot of headache. But now I took some time and studied that. You know, this actually took some days. If you look at the date, today is now 29, and I don't think like it's been a while, like 3 days probably or 4. So audio took me a while. It was very bad to think about because I spent so many time trying to implement it myself. Then in the end, I lost a lot of time. So I just read this. It was like 2 a.m. and I took the time to read this documentation, this miniaudio. I did not read everything actually, only like the introduction and the low-level API, then high-level API. And then I probably did not read the rest because, I read. Yeah, I read a lot of stuff here. But it was enough for me to just understand everything and implement it. So it is now implemented and compiled. So what is next? This is interesting. At this point, I can start writing UI or the core aspects of the engine's architecture, like the scene concept, the game object stuff. But there is one last thing that I want to handle before, because right now, as you can see here, everything I do have is not engine-like specific. I have an audio library, which is great, right? So then I have a graphics library, which is great, and I wrote that for the engine. Then I have the math library that I wrote for the engine too, and then I have the OS library that I wrote for the engine too. There's one last thing that is related to graphics, which is font. I need to handle font, and this is a very important part of an engine, and I want to fix this as soon as possible, right? I'm using STB again to load the font because there's no way that I'll write a TTF parser. It's just too much of a nightmare, so I prefer to get Sam Barrett's library, and then I will do this. It is not hard to understand font, so I'm probably gonna do this very fast, hopefully, and then I have it in a way that we can use in the engine. And once I have that, I believe that everything, all the core parts, all the fundamentals will be done, will be finished. And of course, it will miss physics, right? And I need to implement physics. And this will take a while because I'm not planning to use a library for that. So let's see how it goes. But for now, this is my idea. I will probably gonna work on font rendering, and it will be part of graphics. I will try to make a single file like font.h that does have a class font, and this class will load the font as a TTF file, and then it will create everything and have a method for you to draw a given text to a mesh, because this is how it works. You draw something to a mesh, and this mesh you can use to render as it was any other regular mesh. And the deal is that you need to pass to this mesh the font image. So the STB true type, it will allow you to create an image, a bitmap image for the font itself, and then you can use this to render. So it is how it works for the font. But again, this is the subject of the next video, and this is just an update to say, hey, we have audio. Nice. So that's it, folks. I see you in the next video.